Hi, my name is Jayson Patrick. Welcome to this live demonstration of ELEK Cable HV software. In this demonstration, I'm going to show you the main features of ELEK Cable HV. I should mention that ELEK Cable HV is very accurate high voltage cable rating software, which has been fully validated against CIGRE Technical Brochure 880. This is the main window, and I'm going to firstly show you the cable model navigator. So in the first instance, we should load the cable models into memory, and these models will be used in the studies. So let's look at the cable model editor. We start by opening a new cable model. And on the left-hand side, we can add different layers to the cable, which are matching actually with the cable data sheet. So we can add screens, sheath, armors, the jacket, of course, and multiple layers according to the cable data sheet. There is also a database of pre-modeled cables. Around 400 of those cables have been pre-modeled for easy access. We recommend that you use cable manufacturer data sheets to model your cables. Included with the software are the cable models from CIGRE Technical Brochure 880 for validation purposes. So Cable HV can model all different sorts of cables, from low voltage to high voltage, submarine cables, paper insulated cables, HVDC cables, any sort of modern power cable. Let's take a look at a single core example. This is one of the cases from Technical Brochure 880. If we step through the model, let's just unlock it. Let's look at the conductor. So for each of the layers, we need to define the physical dimensions and also the material properties. So we would start by defining the conductor size. Cable HV supports all sizes of conductor up to 3,500 square millimeters. Metric and imperial conductor sizes are supported. You can even have custom sizes, different classes of conductor, obviously different materials, including custom materials, and different conductor types, including simple stranded copper, aluminium, and millican conductors. There are also hollow conductors and custom conductor types. With the software, you can set custom KS and KP factors if you have them, if they differ from the standard. You can use standard DC resistance, you can specify DC resistance, or you can even calculate it. There are some additional material properties that can be, they're automatically generated or loaded, or they can be customized. Let's have a look at the general settings. As I mentioned, all sorts of different cable types are supported. Single core, 3-core cables, multi-phase, any voltage from low voltage up to extra high voltage, any frequency as well. Let's step through the different layers. Conductor screen. The software automatically picks up these constants that are used. There's a database, and those are picked up from the standard, also CIGRE Technical Brochure 880. We use constants and the guidance points, all the guidance points from that document. Insulation, lots of different insulation types, including custom. You can also set short circuit temperature limits here, your loss factor, all automatically loaded. Installation screen, custom. This 132 kV single core cable has water blocking tape layers, so those are set as custom layers. You can have any number of custom layers in any order. There's a screen, in this case consisting of round copper wires. You can have tapes. We consider lay length factor. Another custom water blocking layer. There's an aluminium sheath. You can also consider corrugated sheath. This is a non-corrugated sheath. And then of course the outer jacket or the serving. But there is an additional outer semiconducting layer with this cable, and that's been added as a custom layer. So let's load this single core cable into memory. Now once I've done that, I'll be prompted to set up these settings, installation settings. I can rate the cable or determine the current rating based on conductor temperature. I can also set a loaded current if I wanted a fixed current. I can set the daily load factor if it's not something other than 1. And of course, importantly, the bonding. Solid bonding with constant or varying phase spacing along the route. I can set the individual spacings. Otherwise, I can set this loss factor. And cross bonding, balanced or unbalanced. All of these settings can be modified, and they will affect the current rating. So let's use single point bonding for this single core 132 kV cable, and that's been set. Now let's also load a multi-core cable. Let's load another one from TB880. Let's load this 30 kV submarine cable. Now this cable consists, I'll go through some of the layers, just unlock it. 630 square mils is the conductor, copper. We have some custom layers, conductor screen, insulation screen, more water blocking tape. It's got a lead sheath, custom layer, the filler. The filler has been set automatically. Another custom layer. It's got armor bedding and armor. Steel wire armor. Let's load that one. For that cable, let's use solid bonding. Now, in this case, in this study, we have 3 cable models that are preloaded, and let's use this one. So now I've finished with the cable model navigator. Now I can move to the main interface. So we'll close the navigator. Now we have the installation conditions along the top here, and we have some additional modules that are included as well. There is a lot of capability with this software. There is not much that you cannot model using ELEK Cable HV. We have installation in air, in groups in air, direct buried with soil dryout, buried in backfill, buried in ducts, unfilled troughs, tunnels, ventilated tunnels, risers and J-tubes, and we have the finite element method. So I'll show you the in-air module first. Now, when I'm here, the cable model that has been selected in the cable model navigator that's currently selected is the one being modeled for the in-air module. So that's that 132 kV cable type. and the conductor size was 1200 square mil. So as I'm in this in-air installation module here now, I can choose the installation arrangement according to the IEC standard. That's where these configurations come from. I can change the ambient air temperature as required. Now what you'll notice with this software is that the current rating calculations, which are fully iterative and extremely accurate, are updated live. You can see the results on the right hand side here. These are the summary results. So the current rating for this circuit in this arrangement here, this 132 kV cable type, is 1670 amps under these conditions. And the bonding is single point bonding. Also we have the complete results. So obviously the calculations are very extensive. Let's have a look at the results. We calculate all of the electrical losses. So there's total losses here, conductor losses, dielectric losses, sheath and screen losses depending on the cable model. Obviously we calculate loss factors in accordance with IEC. We calculate the electrical properties of the cable, including conductor AC resistance, DC resistance, skin effect factor, proximity effect factor, insulation capacitance, screen or sheath, AC resistance. We calculate standing voltages, sheath standing voltages for single point bonded cables. We also calculate and display circulating currents, which I'll show a bit later. We calculate sequence impedances, so positive, negative, zero sequence impedances and surge impedance of the cable. So those can be used for other studies. We calculate, automatically we calculate permissible short circuit currents for all of the metallic layers within the cable. We do that automatically for these short circuit times and for the maximum short circuit temperatures that were set within the cable model editor. So we have, in this case, for this cable model, we have conductor short circuit ratings for shown here for these times. And the short circuit rating for the screen and the sheath are also shown. We calculate and we use for the current rating calculations, we calculate T1, T2, T3 and T4. Those are the thermal resistances of the cable and the external thermal environment. We calculate all of the temperatures, so starting with conductor temperature, that was set to a maximum value of 90 degrees within the cable model editor. And then we calculate from there the actual temperatures of each of the major components in the cable, and those are actually used for the calculations of resistances, etc. at those exact temperatures. Moving on, further below we have all of the cable model details that were set within the cable model editor for all of the components, the conductor, these are the properties, etc. All of the layers within the cable and all of their dimensions and the material properties. So that's the complete results, and those can also be printed directly into a report, a PDF report or an Excel report. So I'll just go back to summary results, but I can flick between the losses, the thermal resistances, the cable temperatures, cable data, etc. Complete results again, or back to summary. Summary is a nice brief view of what's happening. Coming back to the installation, cables in air, we can also consider cables in ducts, cables exposed to solar radiation, we have a very nice inbuilt calculator, which includes a Google Maps integration, so you can put in your exact physical location or the location of the project, and you can calculate, the software will calculate expected maximum solar radiation intensity. There's a lot of different settings here: angle of the surface, the address, the elevation, all that sort of stuff is fully integrated with Google Maps. And we have different intensities for angled surfaces, horizontal surfaces, and vertical surfaces. And those will be used to derate the cable. You can see there's quite a significant impact by exposing this 132 kV circuit to solar radiation. The current rating has dropped quite significantly, so we can turn that off and retrieve that updated current rating. So moving on to cables in groups, the software can consider the thermal proximity effect of multiple circuits in air. For these different arrangements, you can adjust the spacing, you can adjust the ambient air temperature, you can also adjust exposure to direct solar radiation, which, as we've seen before, will have a significant impact. Moving on to direct buried cables, the important factors here are soil thermal resistivity, which we recommend that you measure ideally, or otherwise there are standards. The standards specify standard values for these properties, so soil property. Soil ambient temperature is also very important. So again, you can change these values and the results are updated live. Right now I'm working with the cable model 1, which is this medium voltage cable, 11 kV, 300 square mil. So moving downwards, I can add an unlimited number of cable circuits of any cable type. So let's add some more circuits. Now, the beauty about ELEK Cable HV is that it's fully interactive. So everything is copy and paste. I can copy and paste and move using the mouse all of the cable circuits. I can adjust their positions using the mouse, but I can also very accurately adjust them, their positions using these values here. There are standard configurations, so tree fall, flat, and touching, that I can use. I can also space the cables, and I can have custom positions too. So I can use these inputs here to adjust the positions of all the phases, or I can even use the mouse. And again, like I mentioned, the results are updated live. I'm going to use unequally loaded. So we have these settings up here for isolated ratings, equally loaded, and unequally loaded. So I'll just return that to a standard configuration. Now, as I mentioned, so this is only using one cable type, but as I mentioned, now I have 3 cable models loaded in memory, so I can shift the cable type, I can change the cable type, I can even add another one, and I can use the multi-core submarine cable. So now we have 3 circuits of 11 kV, single core cables, 132 kV cable circuit, and a multi-core submarine cable. The software calculates all of the mutual heating between the circuits and updates the current rating live, as we can see. We can consider, with direct buried cables, we can consider soil dryout, and the software actually also calculates soil temperature contours or isotherms. Moving on to buried in backfill. This is quite similar to direct buried, but it does not include soil dryer due to the IEC standard. But again, we can add an unlimited number of circuits of any cable type and any configuration. So let's put these cables in tree file. We can add a thermal backfill, and again, this is fully interactive. So we can position this thermal backfill, we can resize it. The exact positions and the backfill thermal resistivity is displayed here. It's fully configurable. We can have cables enclosed in ducts, in separate ducts, or combined in a duct. There is a duct selector tool, so we can set the duct like that. The duct can be all sorts of different materials, and we can also change the fill material of the duct. It can be air, water, or a solid filling such as bentonite. Moving on to cables in unfilled troughs. This is a very flexible module. So this trough is air-filled, and I can have an unlimited number of cable circuits, of course avoiding without causing overheating of the cables. An unlimited number of circuits inside the trough of different cable types. This is the 132 kV cable type, and then this is the medium voltage cable type. And what happens is, so the ambient air temperature is 40 degrees Celsius, and the temperature, the additional temperature rise caused by these cables inside the air-filled trough is approximately 17 degrees. I can have groups of these cables. This trough itself is fully adjustable by the mouse, or I can set the exact physical dimensions here. I can expose it to the lid to sunlight. I can add a bedding material underneath. I can also place these cables inside ducts if that were necessary. Moving on to ventilated tunnels. Again, any number of circuits can be added. We have extended the IEC method to allow any number of circuits. I should mention, however, that ventilated tunnels at this point is limited to one cable type for all the circuits, but that will probably change in the near future. So the tunnel is fully configurable, so it can be round or circular or rectangular. You can adjust its dimensions using the mouse or enter its exact properties here. You can change the length of the tunnel because it's a ventilated tunnel. You can change the air velocity inside the tunnel. There's some custom settings here. You can adjust the environmental parameters as well. And again, the current ratings are updated live. Moving on to risers and J-tubes. these are riser poles or cables in riser poles enclosed. The riser may be open at both ends, open at one end and closed at another, or closed at both ends, which is the worst case or most onerous case. We can also calculate the rating of cables in J-tubes for offshore wind farms, which is particularly useful. You can adjust the environmental properties, the ducts, and you can also apply solar radiation using that same calculator that I showed you earlier to the riser or the J-tube. Now, what I've shown you till now are the installation methods strictly adhering to IEC standards and CIGRE Technical Brochure 880. But if you need to go beyond the limitations of IEC, you can use this very unique and powerful FEM tool based on the finite element method. So it works. It only applies to buried installations at this point, but it works similarly to the buried module that I just showed you, but it has some added flexibility. So what it can do, which is beyond the IEC standard, is it can do things like modeling of multiple backfills. So let me just set that up. So this sort of arrangement, for example, using a pure IEC based approach, you cannot calculate this sort of arrangement with separate backfills. Now, being based on FEM, there are additional calculations such as meshing and solving of node temperatures required. So therefore there is a calculate button, and because I'm running this the first time, it's taking a little bit longer, but there is a calculation time of around 30 seconds, I would say, normally, to perform the current rating calculation. It's a full FEM calculation in terms of the meshing and the temperature calculations, and we will see it will return very soon a current rating for us using FEM. Now, one of the advantages of FEM is that of course it can model installations beyond the IEC, but the model itself doesn't have a lot of the poor assumptions or IEC based assumptions included, such as the ground surface being an ideal isotherm when it's not. This FEM module can model convection between the ground and the air, which makes it more accurate. Here we can see the mesh plot. So if I zoom in on the mesh plot, you'll see that we are actually meshing every component of the cable, including the conductor, all of the layers within the cable itself, metallic and non-metallic layers. We automatically mesh the environment, in this case the backfills and the surrounding soil. This arrangement, this setup is all done automatically, and it makes performing FEM calculations really fast and easy and simple. Doing this yourself is very, very time consuming and prone to error. We have a very nice soil temperature plot with FEM where you can see different isotherms. And like I've shown you previously, this arrangement is fully interactive. drag and drop, copy and paste. You can essentially model anything you like in any arrangement. Moving on to the modules now. We have a filled cable tray module. This is quite a unique module. And the main application would be power stations, cables in overhead trays that are fire protected, and where the cable trays are extremely full. That obviously significantly derates cables, and this calculator, using this calculator, you can customize the arrangement of those trays, add different insulation layers and different diversities, and apply thermal resistances to essentially highly filled cable trays to get a derated current rating. Short circuit is included in the main results. I will show you the transient module. This is the transient module, which can perform emergency and cyclic ratings. Looking at emergency ratings first, you can set a maximum emergency temperature, which would be normally above your standard maximum continuous temperature limit of your cable. A typical value may be 110 degrees when the cable is normally rated at 90 degrees. Looking at the advanced settings, you can set a preloaded current. That's the current that the cable is carrying prior to the emergency. And over here on the right, you can see temperature, transient temperature response plot, and you can see the emergency rating plot, where you can move the cursor to get the emergency rating of this cable at a particular time. Let's use the 132 kV cable. Like I mentioned, you can adjust the cursor to get the emergency rating that you want. Looking at the cyclic ratings and the IEC method for that, you can enter a custom load profile and then calculate the cyclic rating to receive essentially this cyclic M factor, which allows you, it's very useful for renewable projects and allows you to get extra capacity out of your cables based on a non-continuous load profile, which is very, very common with renewable energy sources. Magnetic fields. This is a magnetic fields density calculator. So it has automatically, from this buried installation, it has automatically imported all of the cables and their currents and their phases. You can change all of this information. You can switch cables on or off, or even the direction of the current for DC cables, and then calculate this magnetic field density at different heights above the ground surface, or a standard value is at height is 1 meter above the ground. You can change the step size to get more accuracy. And we also have cable crossings module. Now this is another module. It's based on IEC, but we have extended the capabilities beyond the limitations of the IEC. So the IEC standard only facilitates 2 circuits, but we have extended the method to any number of circuits. As you can see here, you can set custom crossing angles and calculate the permissible current rating from that. You can also add heat sources. Looking at the reports, we have direct PDF or direct to Excel reports. Those are essentially the same reports, just in different formats. Excel is obviously editable. I'll generate the PDF report. It's a highly detailed report with clickable links, so you can move to the results for the different circuits, and also the cable models are included in the report. The methods are mentioned, number of iterations, convergence criteria, etc. The current ratings for the different circuits are mentioned, and the conductor temperatures. There's temperature plots, and then the detailed results for each circuit. Those are essentially the same results that we saw in the main program. You have the summary results, cable positions, calculation methods, bonding, and then your losses, loss factors, electrical properties, standing voltage depending on the bonding arrangement, sequence impedances, etc., cable temperatures. Circuit 2, that's solidly bonded. In that case, we can see screen circulating current that is calculated, and all of the different results, and we'll keep going until we find the cable model. So this is one of the cable models. This is the medium voltage cable, 11 kV cable included in the study. All of the cable models that are included in the study are included in the report. This is the 132 kV cable type, and then the 30 kV submarine cable is also included in this report because it was part of the study. And that concludes a very high-level demonstration of ELEK Cable HV. If you have any specific questions, please reach out to us. There is also, of course, a fully functioning free trial that you can register for, download and install. And after that, we'll be more than happy to have a technical discussion with you. Thank you so much for your attention. Thank you for your time, and we'll talk to you soon.